the US alone, there are about 170 species of wild birds that have been affected by influenza. And the majority of those 170 species are just dying from infection rather than recovering.
Remember when bird flu sounded just like a bad tabloid headline? Avian flu, specifically the highly pathogenic kind known as H5N1, isn't just a farm problem anymore. It's not confined to chickens in crates or duck farms in the Midwest. It's in wild birds, in raptors. It's even in mammals. It's rewriting ecosystems to a degree that we do not fully understand, and in some cases, it's devastating entire colonies of seabirds in just a single season. So yes, avian flu is really bad. Not just because of how contagious or deadly it is, but because it's doing things viruses don't always do, like cross species boundaries or cause ripple effects in food webs, or force conservation scientists to put on hazmat suits in the name of seabird rescue. In 2022 and 2023, we saw unprecedented die-offs among wild birds in North America. Snow geese, pelicans, common terns, you name it. And while headlines focused on poultry prices and egg shortages, something much more alarming was happening just offshore. This episode isn't about panic, it's about understanding. Because this isn't just a bird thing. It's a biosecurity thing, an ecological thing, a climate thing, an everything is connected thing. And to help us unpack the true scope of what's happening and what might be next, we'll talk to disease ecologist and assistant professor at UMass Boston, Dr. Nichola Hill, who studies how diseases emerge from animal reservoirs in an increasingly human-impacted world. But first, let's zoom out. How did avian flu get here? Where is it going? And how worried should we actually be? It started quiet, as these things often do. A few dead geese in southern China in 1996. The virus was labeled H5N1, another entry in the alphabet soup of influenza strains. But this one was different. It didn't just make the birds sick, it wiped them out. And within a year, it had made the jump scientists always dread, from bird to human. In 1997, Hong Kong saw the first human infections, 18 people with 6 deaths. The government responded by culling every chicken in the territory, 1.5 million birds gone in 3 days. It was drastic and chaotic, and for a moment, it seemed like the story was over. But viruses don't retire. They mutate, reassort, and then reappear. Through the 2000s, H5N1 simmered across Asia, from duck farms in Vietnam to backyard coops in Indonesia. Wild migratory birds carried it along their flyways, turning wetlands into viral highways. And by 2005, it had reached Europe and Africa. Scientists began calling it highly pathogenic avian influenza, or HPAI. The phrase sounded technical, but what it meant was mass mortality. Tens of millions of domestic birds were culled. Millions more wild birds died outright. And every so often, it jumped again into humans. Not efficiently, but lethally. Roughly 860 people infected since 2003. More than half of them didn't survive. Then came the lull. From 2010 to 2018, H5N1 seemed to fade into the background noise of global disease ecology. But beneath that quiet, influenza's restless genetics were busy remixing themselves. Other avian strains, H7N9, H5N6, and H5N8, took turns in the spotlight. The world moved on until 2021. That's when the new lineage, clade 2344b, spread like wildfire across Europe, Africa, and the Americas. It hit wild birds harder than any previous version. Pelicans, puffins, eagles, albatross, entire colonies erased in a single breeding season. By 2022, H5N1 had arrived in North America. It leapt into skunks, foxes, seals, sea lions, and even polar bears. The virus wasn't just crossing international borders, it was crossing the animal kingdom. And suddenly, the story wasn't about poultry anymore. It was about ecosystems unraveling. Egg shortages made headlines, but behind those, biologists in Tyvek suits waded through beaches littered with dead gannets and terns. Entire species, like the California condor, were once again under existential threat. We're now in 2025, and H5N1 hasn't gone away. It's still reshaping the interface between wildlife, agriculture, and people. The World Health Organization tracks sporadic cases in humans, while the USDA monitors outbreaks in livestock, including, for the first time, dairy cattle. It's a new frontier for a virus that refuses to stay in its lane. The biggest question isn't whether H5N1 will go extinct, it's whether it will adapt. Could it become the next pandemic strain? Possibly. But evolution doesn't guarantee inevitability, only opportunity. So here we are, nearly 30 years after that first goose in Guangdong. A virus that began in a pond has now circled the planet. And it's reminding us, again, that health isn't siloed by species or borders. It's one shared system, one connected world. Stay tuned. Okay, well, welcome back, everyone. I'm really excited to be joined today by Dr. Nichola Hill. Thanks so much for joining us.
It's my pleasure. Thanks for having me.
Of course, yeah. I thought we could start off thinking about how did you start working on avian flu, specifically H5N1?
So I had finished my PhD. You can probably tell from my accent that I'm not from the US. I'm originally from Australia. And I was studying the evolution of parasitism in marsupials. So these are mammals that have pouches and they have really immature young. They're so different from birds. And that required this really strange mix of skills like immunology, parasitism, phylogenetics, GPS tracking, GIS. So I do like to study other things, but I have to say, bird flu has kept me really busy.
How is this current strain different from past versions of avian flu? Because flus have existed throughout history, but this one, H5N1 or HPAI, highly pathogenic avian influenza, seems different. Can you tell us a little bit about why it's kept you so busy and why it's so different?
Yes. So this particular strain of H5N1 just seems to have really high fitness in wild birds, and that's new. So it basically means that the virus is able to replicate really quickly and really well in wild birds, and that was not always the case. Originally, one of the original strains, if you go back far enough, the Goose Guangdong 1996 strain, that tended to be far more fit in poultry and not wild birds. And so it would replicate to high titer. Yes, it would kill poultry, but it was not fit in wild birds at all. And so it's been this really strange process of watching this virus evolve over time. And in around that 2020 period is when that original 1996 Goose Guangdong lineage, which is like the parent for all of the deadly H5N1 viruses that we see kind of ravaging the globe, honestly, at the moment, was the birth of clade 2344B. And I'm sorry about the really forgettable name, but I really think the most important part about that is that something switched. And we think it was this sort of episodic evolution where the virus tended to be able to replicate really well in wild birds. And that is good and bad. So that meant that there are wild birds who are capable of recovering from infection now and are capable of asymptomatic or silent spreading, a bit like typhoid Mary. And so they're not some water bird species, and we can get more specific, I really mean waterfowl, are able to actually control infection. But the other devastating part to that is that because we have a silent spreader in the midst, the virus is also spreading really quickly in wild birds. And so that's really unprecedented.
Yeah, that's so fascinating. So at this point then with H5N1, well, I guess the early 2020s when it really started ravaging wild populations, what species of wild birds seem to be most vulnerable right now? And why do you think it's those lineages or species versus others?
You're right about the 2020 shift in the evolution of this virus. And we understand that this is the biggest outbreak in wildlife to date of any disease, actually. Simply,
Really, of any disease?
yes. So we think that this is
Wow.
the case, although I'm also going to chime in and say quantifying the mortality in wild birds is incredibly logistically challenging. So we're only
Yeah.
left with estimates of how many birds have died, but we think that the sheer number of individuals that are dying accumulate, and we're probably somewhere in the, 1 to tens of millions of cases of infected wild birds. And that is probably a major, major underestimate. I was pondering this question, and I think when we look at the US alone, there are about 170 species of wild birds that have been affected by influenza. And the majority of those 170 species are just dying from infection rather than recovering. So we think it's a very, very small fraction of species that are really contributing to this asymptomatic spread. The large majority will be infected with the virus and will quickly die in the wild. So this virus is deadly in the majority of birds that it comes into contact with. So if you take on face value that estimate that there are roughly 1,000 bird species in the US, 17% of species in the US is a substantial chunk of our avian biodiversity. And so that is pretty alarming.
Yeah.
In parts of the globe, such as the UK and Canada and other parts of Europe, actually, they've had consistent and quite thorough surveillance. And we've seen seabird colonies particularly devastated. So we're talking about northern gannets and Arctic terns and common tern colonies hit really badly. So, for example, in the UK, great skua populations, we lost about 70% of our breeding adults in a single year.
Wow. I don't think a lot of people think about how long birds live.
Right.
But these bird species you're talking about, like seabird species, are typically very, very, very long-lived with very low adult mortality, and they have very low reproduction rates. So you need these old birds to be around a long time for these populations to be maintained. And if we're losing 70% of a population of adult birds, that's like catastrophic.
Yeah. I don't know if you've ever seen any footage of a wild bird infected with flu. It usually involves initially some kind of respiratory infection. So sometimes we even see agonal breathing. So it's a case where the lungs are involuntarily actually expanding and collapsing. And so that's awful to see. They're often disoriented, uncoordinated. We've walked out wings splayed, but they cannot fly away. Often we get reports of drunk birds. So that might give you an image of a bird that's walking around in circles or is completely unbalanced and disoriented. And of course, there are these neurologic symptoms that contribute to some of the observations that we're seeing as well. In some cases, diarrhea as well, but it's usually it's just this kind of gruesome way to go. I don't know that I can explain it as being fast. I think it probably takes hours and it depends on the bird, but I think listeners, if they see anything out of the ordinary, it would be a bird that looks completely disoriented and is unable to fly, depending on what stage of infection that it's at. And it's usually heart-wrenching. But I've also seen videos of common terns, and they have really interesting behaviors where the other terns on the colony will push that infected bird that's like visibly ill and infected off the colony and effectively try and drown it. So there's something about, protecting the bulk of the population. They do have like a strong instinct to push away a bird that is not behaving regularly. That's a kind of like a dark and scary piece of some of the things that I've seen. But it's Yeah, it's horrific to observe. Yeah.
Yeah, and thinking about the scale at which that's happening is kind of mind-blowing. The question that obviously comes up right away is there any good news? Like, are there vaccines that work? Is there resistance that's evolving? Can we see that happening already? Or any other hopeful kind of adaptations that you know about or have been looking at?
On the bright side, you know how we were saying that in the US alone, we've had 170 species infected with avian influenza virus. That number has actually really stabilized in the last year, and it's now no longer rapidly expanding its host range. So it seems to be consistently occurring, if you can consider that a bright spot in the same species.
Well, yeah.
With fewer and fewer new species being infected. In other good news, the California condor, which I think honestly, that's a success story. Vaccines have been effective and we've seen rebounding populations, which is great news. I think the caveat with that is that vaccines are great for populations that are spatially clustered and small and they're not dispersed long and wide. And so they have like a dense colony, for example. But I don't know how practical that is for a lot of the wild birds, especially in North America.
Yeah, you can't just push a text out and remind everyone that Safeway has the flu vaccine. Yep. It's interesting. I guess for people that don't know, there are vaccines that we can administer broadly because they don't need to be injected, right? Like the rabies vaccine is dropped in little food pellets all over North America to keep rabies under control, but that just wouldn't work for this kind of virus. So
I think the mutation rate is too high. So it's constantly a need to make sure that we have a match between the antibodies and that the vaccine will teach these birds to produce an antibody response that can neutralize the virus. But do those antibodies match with what is circulating the next year or so on? So I think it's the similar reasons to why we have to update the human seasonal flu vaccine that's going on in wild birds too. So tricky. I think we do need tons more interest and progress in those areas of how to vaccinate and deliver therapeutics to wildlife. I think we haven't done enough, and there's some really interesting technology that needs to be taken advantage of. And now is the time.
How do you, as someone who's focused on this research, and part of your website is Dead Bird Alert, where you want the public to let you know if they're finding certain types of dead birds, how do we balance public concern and science communication on topics like this, which are inherently heavy, but that we really need to lean into understanding more?
Yes. So I think that I would say that we probably don't have enough awareness of what's going on with bird flu in wild birds right now, let alone poultry, as you were saying. Like, let's just, for a minute, just put a pin and maybe come back to the fact that this is like billions of poultry. This is like spilling over into dairy workers in the US. And
we haven't even talked about the fact that it's like jumped to mammals and is considered endemic now, I think, in dairy cattle in the United States, which is, for avian flu virus, that's crazy.
It's the number of times I've fallen off my chair thinking that will never happen. And avian influenza keeps me extremely humble with learning again and again what it means to be a virus in animals and its ability to evolve. But this is really shocking and surprising is the number of cases. We've got 17 states in the US in which this highly pathogenic H5N1 clade has shifted into cattle, and it's not causing them to die, actually. So it's sort of reproducing in really high titers in milk, and that creates conditions for dairy workers to be exposed, especially if a lot of the mechanical machinery is not being cleaned fastidiously enough between milking cows. And so it's just incredible. I will say, though, that situation is really unique to the US. We have not seen...
Oh, it is? Huh.
Uh, it's really interesting. Europe's on high alert, other places as well, but they just haven't seen it. Bird flu typically sticks to aquatic birds. And I think that is broadly true, but we're discovering with this increase in host range that we definitely do have these cases of interesting passerines being impacted. I think what's interesting about starlings and flocking birds is that individually, it turns out they're not that great at replicating the virus, but in really big numbers, they can. And so it has to be that bird in a big, dense group of birds, also coincidentally feeding on grain at an interface like a farm that creates those conditions. But I say that it's just a math game, right? I mean, we have more and more of those conditions that are occurring because of that really kind of increasing interface between wildlife and domestic animals and human activity. So again, I think that's also part of this puzzle as well. So I think it's, we say that it's still safe to put out your bird feeders. It shouldn't really transmit among our backyard birds. This is really rare cases, and we don't see really big mass mortalities in birds like American robins or jays, for example, those types of species. But keep your eyes peeled, because I think there are certain ecological conditions that do create these, these favor these particular infections that are really, really interesting and obviously devastating as well. But there's so many ways in which we're also learning about birds through bird flu, in the sense that we were talking about how wild mammals are being infected, and often these are carnivores. So, red-tailed hawks along with red foxes and coyotes and bears, those food web interactions are playing a really big role in transmission up the food chain. And I think it's, allowing us to sort of appreciate how complicated some of these food webs are, and what kind of species are being preyed on. But for sure, I think for a lot of those carnivores, the fact that they might predate on wild birds is a big risk factor.
I mean, there's like 70 species of mammals now that we've seen this jump into. And like you're saying, they are mostly carnivores. So they probably, specifically the terrestrial ones, are probably being infected by eating a bird that was easy to catch, because that bird was dying from bird flu, which is, crazy to think about.
But I think you're right about that point where, carnivores explain some of those mammalian infections that we're seeing. But then also, it turns out that bird flu can spread amongst a lot of these marine mammals. And so I think we had big outbreaks going on in parts of South America, including Peru, of sea lions and dolphins, for example, have also been impacted. It's just, this is an interesting virus that has some really interesting transmission pathways, and that factor where birds are in proximity to marine mammals or other marine wildlife also creates these conditions for really big spillovers. And we see giant mass mortalities in those species as a result, which is, again, pretty humbling to see and watch.
It's not easy to jump hosts. I mean, we focus on it because it's like, outbreak. And obviously, like, we've been living through a pandemic where it was probably a organismal host that jumped into humans. And I think people think it's easier than it is, but it's actually quite difficult. So the fact that H5N1 is this like super virus at jumping around is something I had stressed to my ornithology class, like, is definitely something to watch. For anyone listening, for birders listening, anyone out watching wildlife, if they see a dead bird, what are your recommendations for what they should do?
Document it if you can from a safe distance. And then it's worth, every state has an agency where they're actually counting and reporting dead birds. So it's usually at the state level where there's some kind of repository of that kind of information.
For sure. In Colorado, it's Colorado Parks and Wildlife. But I think if folks look up like bird flu report, it shouldn't be too difficult. And like you said, it's usually state level.
Yeah, there's some good apps. So iNaturalist is starting to include a dead beached birds or dead birds particular group that you can document your photo and tag them. And those are really, really good. They're often community run and they get really, really good information from coastal locations that we see. So they've provided a bit of a model for how it could work, integrating an app as well as citizen science for sure.
So we've reached the part of the show we call That's BS, or That's Bird Stuff, where we give our guests an opportunity to debunk a myth that ruffles their feathers or to share a fact that they think our listeners should know. So Nichola, what do you want to call BS on?
I want to call BS on the fact that wild birds are key to the evolution of this virus. That is not at all the case. Evolution of highly pathogenic avian influenza only happens in domestic poultry. And so in many cases, wild birds are just the victims of this interface and spread. So for example, this is a virus that has evolved to become more deadly because it's in a particular setting where there's large numbers of animals that are really immunosusceptible. They're often genetically similar or clonal. And the virus does really well in those types of conditions. And there are no consequences to evolving to become more deadly or virulent then because of the really high turnover of production of particular poultry species. That scenario would never happen in the wild. As we know, there's this virulence transmission trade-off with viruses, and it's more important for the virus to actually transmit and spread rather than kill its host. And so we're hoping actually that over time we might see some of that occurring in wild bird populations across the world in response to influenza, in the sense that they can impose an immune selection or immune pressure on the virus to stop being so deadly and actually recover. So we might start to see evidence of that in the wild, but poultry is often the root of the problem. And in thinking about that, I think there's lots of different ways and solutions to come to terms with avian influenza that exist when we're talking about poultry that are much harder to implement when we're talking about influenza spreads in nature.
Well, Nichola, thanks so much for joining us. This is obviously a really heavy subject, but it's a really important one, and we appreciate you sharing your expertise with us.
It's a pleasure. Thanks, Scott, for having me.
Okay, so birds are dinosaurs, and around here we like our snacks. So we end each episode with a dinosaur nugget. Today's dinosaur nugget is that observation is a critically important tool in combating bird flu. What we know about bird flu in wild populations has been greatly informed by birders and citizen scientists. I encourage you to keep an eye out on your surroundings, document and report unusual bird behaviors or deaths to help your local authorities track the impact of this unprecedented virus. That's a wrap on this week's episode. Okay, but bird flu is really bad, right? If you like this episode, leave a comment, like, and subscribe. We'll catch you next time. Bye. Okay, but Birds is hosted by Scott Taylor, with production and creative by Zach Carl.